Good evening, everyone. Welcome to session with 360DigiTMG. And as part of the Pharma Analytics domain, we are conducting a series from starting off our data science, like all algorithms we are discussing, and we have reached till forecasting. So today we'll be discussing about forecasting the sales data, the pharma sales data especially. So before moving into that, so let me tell about myself. So my name is Sandhya, and I'm an AI consultant and as well as a trainer in 360DigiTMG. So today I'll be helping you in understanding what is forecasting and how can we implement that in the pharmaceutical industry. So we all know that there are different domains across the globe, and everywhere we have the data, and wherever we have the data, we can implement the our data science, data analytics, machine learning. So everything, all these algorithms everywhere, we can implement them, we can apply them and understand about the data itself. And yeah, now we are closely looking into the pharma sales data. And before I further proceed, let's recap what all you discussed in all these sessions. So from couple of days, so you are understanding how machine learning can be implemented in pharmaceutical industry. So in a specific domain. So it's called a domain analytic. So in a pharmacy, in pharmaceutical data, there are like different kinds of data about the drug, about the different kinds of tests to find out the how long the drug will live, right? So many things are there. So in all these things, you have already discussed how can we apply different algorithms. So let's have a look at them. Let's understand. Let's recap what all we discussed uh, till here. So I would strongly suggest all of you to go to the mind map, which is very helpful, which is present in 360DigiTMG website. And I quickly opened it. So if you go here, we have something called as CRISP MLQ, right? So cross industry standard process for machine learning, and it also used for quality assurance. And this is kind of project management methodology which we are going to see, and you have already understood about it when you are implementing the entire project. So you have a data, and how can we process the data? How can we get some insights from it? How can we predict the future? So machine learning is all about predictive modeling, what happens in the future. So what uh, business decisions or what business insights I can get from the past data, or how can I use it in my future. So as part of this CRISP MLQ, we have 6 stages or 6 phases, you can call them. So the first phase is understanding the business. So whatever problem statement you take, whatever use case you take, you need to apply these all 6 phases, friends. And the first and the foremost thing is understanding about the business problem. So as I said, data is present everywhere, in all domains. There are different kinds of domains like pharmacy, like manufacturing, automotive, social media, and many other sectors are there where the data is available. And currently, as we are looking into the pharmaceutical industry and how the sales data will be, especially in this particular industry, we will understand using the business problem. That is our first phase. So in that first phase, in addition to that, we have something called as data understanding, right? It's about understanding the data. So what kind of data we have? Let's say when I talk about pharmacy, there might be different kinds of drugs, different names for its drugs, and also their expiry dates might be different, their chemical compositions might be different, right? So much is involved when I say about data, and particularly a specific domain data. So we have to have a little knowledge on that. What is this data is all about? I hope all of you know. And the next phase, the second phase we have is the data cleaning, or you can also call it as a data preparation part, or EDA, or feature engineering. exploratory data analysis. So I hope as part of this curriculum, you have already understood what is EDA, what is data cleansing. So basically in this phase, we will understand what is an outlier, how many outliers are there, what are the missing values. Let's say for a specific drug, something like take aspirin. So in aspirin, there might be some kind of chemical composition. So there might be some data, missing data, right? So how can we handle that? So how can I replace a value? So if there are any outliers, any misplaced data is there, right? So how can we handle that situation? So everything we will understand, we will analyze the data and prepare the data for modeling in the phase of data cleaning or feature engineering. And of course, when I say feature engineering, we have to select the more important features. So all features are not necessary. What are the main components of a particular chemical or a particular drug? So you have to identify and then remove the others, right? And then we have the third phase, the data mining phase, or it is also called as machine learning, right? So in this phase particularly, we try to implement the machine learning algorithms. So speaking about machine learning algorithms, we have two types. One is the supervised learning and one is the unsupervised learning, right? So in supervised learning, we know the output, we know the label. So the output of the data we know, but whereas in unsupervised, we don't know the output. So we just use some clustering, some segmentations, just identify certain groups, something like survival analytics. We don't know what will be the output, but still we try to understand and get some insights about it. And once after we implement or we model the given data, then we have to evaluate. So how far it is true, right? Is it a overfitting model or a underfitting model? We have to understand by evaluating the model. And then we have something called as model deployment. So if I build a model, it will be in my system. Maybe if I'm using any specific programming language, let's say Python or R, let's say if it is Python, I build a model using various IDEs, right? Integrated development environments. And let's say I used PyCharm or I used a Spider or a Jupyter. And if I build a model, it will present in my system how others can use, right? So we cannot, others cannot use it, right? Imagine like you have a pharmaceutical company and you want to help people. Let's say during COVID situation, we cannot go out. We cannot go out to a retail shop, pharmacy shop, and we cannot take, if I'm not feeling well, I cannot take a medicine. I cannot buy it. I cannot visit a doctor. So everything is online. Now in that case, everything is online and you want to help the people. Let's say you have built a machine learning model. Let's say you built a chatbot, so which can interact with the patients 24/7, right? They can give some, it can recommend some medicines by taking some the symptoms as an input. So let's say if you go to a doctor and you say some symptoms, he'll immediately prescribe a medicine, right? So similarly, your chatbot, based on the training, based on its input data, it can also help others in prescribing the medicines. It suggests something, right, by understanding the symptoms. So if you have built a chatbot, if it is there in your system, it is of no use. You have to integrate it with an existing website or create a new website. Or even you can also create an app, a mobile app, an Android app, or an iOS app. So that is all basically a deployment means. So once the model is built, we have to integrate into an ecosystem. It can be on a website or it can be an Android app, right? So this all happens in model deployment. And then we have monitoring and maintenance. So once it is deployment is done, the job is not done. Still, we have to maintain it, monitor it. Let's say, as we are talking about the chatbot, you have built a chatbot and everyone is using, and your business was success and everyone's so amazed. Now, uh, initially only 100 people are visiting your website to use a chatbot, and later on the crowd is increasing, the traffic is increasing. So 100 change it to 1,000, then 10,000, then 1 million. So many people are coming up. So there might be some issues in the model because it is taking too much of load. Your server is taking too much of load. Your model is taking too much of load. Too many requests are coming. Then we have to monitor and maintain. And also, as we, as years goes on, there are like new diseases are coming up and new advancements in the various chemicals that we use, various drugs we use. Many new advancements are coming up, right? So in the pharmaceutical industry especially, they are coming up with the new drugs, new companies are coming, new compositions are coming. And so whenever the data is updating, when something new is coming, it means a new data is getting added. So when new data is getting added, you have to retrain your model. So you have to do a maintenance, right? You have to retrain the model so that the chatbot can answer the new type of questions as well. So this is all a part of your crisp MLQ. These are the 6 phases of crisp MLQ. And I would strongly suggest go to this mind map, and when you just need to double click, you'll get all the key points that you discussed in the previous sessions. So let's go back to our topic, that is nothing but the forecasting. And yeah, so before I start forecasting, let me just tell you about the data. So you all know that the data can be of two types. So the structured data or the unstructured data. So structured data means the data which is present in the tabular columns, right? Which has rows and columns. So this kind of data, we call it as structured data, right? And if a data which is present in the form of images, videos, HTML pages, JSON pages, and different formats, PPT, Word document, emails, web pages, all these are called as the unstructured data, right? And there is also one more type of data which we are going to use called as time series data, right? So we are going to now talk about the time series data, right? So if a time component is present in your data, so that data we call it as time series data. So when I say time component, immediately when I say time, we all think that the time in the clock, maybe at 6 o'clock, 7 o'clock, 6:30. So that time we assume that is time, yes, but time can also be the days, weeks, years, right? So I can say like 25th May, 6:30. So it's a time, right? And if in the data, if time component is present, we call it as time series data, right? So the time can be anything. As I said, it can be daily data, right? Consider, like we have pharma sales data. So imagine like there is a pharmacy, so the store where every other day, maybe from 9 to 5, everyone will go and buy some stuff, buy some chemicals or some drugs, etc., and they come back, right, according to the use. So whenever a person is buying something, buying some stuff from a store, the data is stored in the database, right? Because the transactional data, right? The transactional data is a structured data. So when I say structured data, it has rows and columns. So imagine like we have a row. Let's say there is one person and he has taken up the some drug. Let's say in the first row we have the person name. Let's say the person name is John, and then he is trying to buy a drug. Let's say maybe aspirin. and at what time he is purchasing. Let's say at 7 p.m. So 7 p.m. IST he's trying to buy, and maybe the drug cost is let's say 100 rupees. So this is the data we have, right? So a particular person name, or maybe a mobile number. So some stores usually take a person name or a mobile number, or just try to capture only the drug name, price, and the time. Sometimes they also capture the person name. And yeah, definitely person name is not necessary when we want to track how many drugs are being sold for per a day, right? So whenever a transaction is happening in a pharmacy, so the data is captured and it is stored in a database. It is stored in a database. So the database can be any database. It can be Oracle database, MySQL, Postgres. There are different types again. So in a database, we store the data, right? And again, the database can be on-premises data, cloud data. So when I say on-premises data, imagine like your computer. So in your computer, you have a RAM, you have a ROM, right? You have a hard disk. So consider that as your on-premises data. And we always synchronize our mobile with a Google Drive, right? To save our pictures, videos, and etc. So that is called as a cloud storage system. Google Drive is a cloud storage system. So when you have huge amount of data and you don't want to set up your own server, we go with the cloud systems. And again, this database can be anything. It can be within the organization, or it can be rented out from a cloud. Now, all this data is captured and stored in the database, right? So imagine a person is going into the pharmacy and he is uh, taking some medicines, taking some drugs at particular time and paying particular amount of money. And each of this data is captured. It is captured. So when you're scanning a drug, and at what time it is scanned, and what is the drug name, so how many sheets you have bought, so all this data is captured. And once this data is captured, now we can use this data for some analysis, right? And in this data, we have something called as time, right? Of course, date will be there. I just forgot to mention it. So imagine there is a date and time. So when you have this particular component, this is one column, right? So we have a column, serial number. We have one column, name of the customer. Next, we have name of the drug. And next, we have the time at which they bought, and then the amount. Maybe sometimes we can also have quantity. So how many sheets of aspirin he bought, or how many, how many grams of it they bought. So the consistency, or the quantity of the drug. So we can also track that, right? Now, if you have a time component, we call it as a time series data, right? When we have a time component, we call it as time series data. And when you have time series data, we can use it for forecasting. And basically, what is forecasting? Forecasting means to identify how future looks, right? So let's say in this month, there are like, 100 people purchased the aspirin drug. Maybe they purchased, let's say, 10 sheets. Now, in the next month, how many they will purchase? Will my sales go up, or will my sales go down? Right? So will my sales go up, or will my sales go down? And what will be the exact number? So in the month of May, so let's say 5 people purchased, or for the whole month, certain number of people purchased 100 sheets of aspirin. And now in the next month, in the month of June, what can be my profit? How many I can sold, right? Can it be 10, or will it be 5, or will it be 20? So depending on the previous data, the past, the historical data, we will try to forecast how the future is going to look. So which drug has more demand, which drug has more sales, all these details we can understand when we forecast the given data, right? And this is the data we are going to see now. So the pharma sales data, so how many drugs are being sold, what is the quantity of them, and the forecasting of the data we can do using forecasting time series. So this is one particular technique we are going to use in this particular module, right? I hope everyone is following. Let me just move to the next slide. Yeah. So as I said, and we'll have a basic introduction about what is time series, what is forecasting, and various other components as well. Then we'll go into data understanding. So we'll go in a crisp ML process, friends. So the first step is understanding the business problem. I hope now you got a little idea what is this time series about, what is forecasting about, and now let's try to understand a little more in detail what is this time series is all about. So the time series decomposition, or the time series, is all about having regular time intervals. It can be hourly data, so it can be daily data, it can be weekly or monthly. So as we are discussing about the sales data, right? So now when you want to analyze the data, you can do monthly analysis. So as we discussed, for the month of May, for the month of June, we can analysis based on the month. We can also do analysis based on the days. Let's say May 1st, what is the how many sales are happened on a 2nd of May, on 3rd of May, on 4th of May. Daily I can do sales analysis, and also hourly I can do, let's say on 2nd of May, morning at 9 to 10, in in the first hour, how much sales I have, and in the second hour how many drugs I have sold. So hourly basis also I can do. Similarly, monthly basis, yearly basis, and also we have quarterly basis. So basically we have like a 3 quarters, and right, we can do the quarterly basis as well. So the analysis can be done in any form, friends. And if we look a little detail into time series, and the time series has some components, right? So time series is broadly classified into two components. So time series is classified into two components. One is systematic component. Right? One is the systematic component. So the components of time series that have consistency or the reoccurrence, they can be considered as systematic component, right? Like as I was saying, weekly, monthly. So when I say monthly, month is the consistency, right? Jan, Feb, March, April. So monthly. So there is some reoccurrence of the data every month. So there is some consistency available. And let's say we have one more component called as non-systematic. So we have systematic component and non-systematic component. So the components of the time series that cannot be directly modeled, or this kind of non-systematic components occurs because of let's say because of wars, or because of some natural disturbances, like let's say COVID. Because of COVID, there is a sudden spike of sales of certain drugs, and when it cooled down, and when everything is back to normal, and the sales of that drug also normalized, right? So only for certain peak time, Let's say in these 100 years, it is only occurred only one time, right? But let's say when I say systematic component, it occurs every month, every day, every other day, right? It is a systematic component. If it occurs on a consistent basis, like if a certain thing occurs every monthly, every weekly, hourly, or any of them, it can be hourly, it can be monthly, it can be yearly, then we call it as a systematic component. If it occurs only very rarely because of maybe natural consequences or some unrelated issues, it can be considered as non-systematic. Now, systematic is further classified into three types, right? Systematic is further classified into three types. And what are they? They are, let's say, systematic is further classified into three types. They are level and trend and seasonality, right? So level, trend, and seasonality. So these three are called systematic components. So we'll see about them, what are there in detail. These three are called systematic components. And whereas we have noise. So noise is called as the non-systematic component. So noise is called as the non-systematic component. So what is this level? So level means the average value in the series, or you can also call it as mean of time series data, right? Mean or average is same, sum of all your data by number of observations. So that is your level, the average of all the values in the time series data. Next we have trend. So trend means the increasing or decreasing value. So the increasing value or the decreasing value in the series for a certain time, for a certain period of time. Let's say if you consider trend, consider number of COVID cases in a year of 2020, right? So in the year of 2020, what is the number of cases per every month? So per every month, the number of cases are increasing. It's a trend. At the same time, look at the drugs that are being sold, a specific kind of drug. So that is being sold, right? It is also increasing, right? So it is called as the trend. And then we have seasonality. So it is like repeating the short-term cycle in a series. Let's say during rainy season, so most of the time during rainy and winter, people will get sick. They might have some viral fevers, cold, and at that time, a specific kind of drug will be sold very high, right? And let's say after next season, when summer comes in, so no one will feel any cold or fever or cough, so those will be reduced unless and until they have any chronic diseases, right? So again, the sales of that drug will decrease. So it is seasonality. So it is repeating in a short time cycle, like every year it repeats. It is called as seasonality. And then we have noise, or it is also called as a residual. It is the random variations. As I said, like COVID, right? It happened all of a sudden, only once. It is not repeating. We are not going to experience every quarter or every month or every year. We are not going to experience, right? It has ended. Only certain period of time, so it has been experienced. So it is a non-systematic component and it is called as noise. So these are the components of the time series data. And yeah, and next few more things, let's discuss about a few more things, friends, like the feature engineering. So as I was saying, we have to understand about the feature engineering when we are talking about the data understanding. We understood about the business problem, and now let's understand about the data. So what data we are considering, how the data is collected, and what the data is all about. So here we have considered the 6 million transactional data that is collected in 6 years over a period of 2014 to 2019. And of course, we have a date and time of the specific pharmaceutical drug along with the brand name, and also how much of the quantity is sold. So what is the amount of particular drug is sold along with its brand name. And as by doing some analysis, we understood that. So instead of categorizing them or forecasting them based on the brand name, we can categorize them based on the drug types, right? So there are different types of drugs. And let's say what are the categories we considered and how we combined them. So there are basically 8 categories we have considered as per the ATC. As per the ATC system, anatomical, therapeutic, chemical category. So based on that system, we consider these eight categories. Let's say we have named it as M01AB. So in this category, we considered inflammatory drugs such as aspirin, indocin, these kind of drugs we considered, and also like non-steroids, acetic acid derivatives, and all related substances are put under category M01AB. And then we have M01AE. So in this also we have some kind of non-steroids and propionic acid derivatives, right? And also some of anti-inflammatory drugs. And then we have one more category called NO2BA category, right? And it has some other analysis and something like codeine, phenyl hydrocodone. So these kind of drugs, mepridine, these kind of drugs are considered in this category. And then we have the next category where we have NO2 B by B. So this is also one such category we considered. So where we also considered about anylides and some other analgesics categories. And then we have NO5B, and where we consider drugs like zaleplone, triazolone. So these kind of drugs we consider. These are all psycholeptics drugs, and of course, and other sedative drugs are considered in NO5C. And then we have R03. So these are for drugs for obstructive airway diseases, right? And such as terbutaline. These kind of drugs are considered at RO3. And then we have R06, where we considered some antihistamines for systematic use, right? Such as cetirizine. So these kind of drugs are considered in this category, R06, right? And based on a specific system, ATC code features. So we have considered and we have collected the data. And of course, the data is collected on hourly basis, daily basis, monthly basis. But in this today's session, we will be looking into the daily sales rather than going with hourly sales or weekly or monthly sales. So we'll concentrate on daily sales in this particular example. So this is all about data, friends. So basically, what did we do? We considered all the data like as I told from a pharmacy, and the data is classified into various categories, right? We have put the drugs based on their chemical composition, based on their usage, for what type of disease they are using, what are these drug categories. Based on that, they are classified into 8 categories. These are the 8 categories that we have taken. And yeah, this is about data, this is about feature engineering. And then let's understand about the analysis. So whenever we are doing the data preparation, it's very important to understand the data, right? And when I say understand the data, it's not only about understanding the column names or understanding what is inside the Excel file or the sheet, but also it's also about understanding the relationship between the variables, right? And we measure it using certain components like correlation, autocorrelation. So we use these kind of methods to understand how the data is related, how my daily sales is related to other variables, let's say according to the time. So we have something called as correlation. So correlation means how each and every variable is related. So how variable 1 and variable 2 are related, how variable 5 is related to variable 6. So it's all about understanding how different variables are related and how they are related to output, right? So how they are related to output, how they are related to input. So this is about correlation, but we cannot directly use correlation in our time series data, right? Because when I consider daily data or monthly data, so every month I'll have similar kind of data. So my correlation will be automatically high. So we need to use some different strategy to identify the relation between these variables. So we use something called as autocorrelation. So in autocorrelation, it is specifically used for time series data where we consider the lagged variable. So we consider a lag. So lag is nothing but a value of a time gap. So it can be lag 1, lag 2. Let's say if I want to consider today's data as yesterday's data, means it is lagging by 1 day. If I considered this month's data as previous month's data, then I just consider as lagged by 1 month. So lag is one of the main important component when we are working with the time series data, right? So and we lag the variable and we find out the relationship between our variables, our inputs, right? And in order to implement this forecasting and to understand about time series data, we are specifically using ARIMA model. So ARIMA model is nothing but auto-regressive integrated moving average. So auto-regressive integrated moving average. So we use this particular technique to implement our forecasting algorithm, right? To forecast the data, we use this particular model called ARIMA model, right? In short, we call it as ARIMA, and the full form is auto-regressive integrated moving average. And we will understand in detail what is this ARIMA is about. So it has a certain factors and certain hyperparameters. Let's look into it. So as I'm saying, ARIMA model is used for modeling our data or in order to implement the forecasting, right? So ARIMA models are like most commonly used tools for forecasting, and by the especially for univariate data, univariate time series data. Of course, there are many methods are available, friends, to implement the forecasting, to forecast the data. Like we have ARIMA, auto-regressive models, we have additive models, we have multiplicative models, we have neural networks, especially we have LSTM, long short-term memory models. There are different types of models that are available. And here, as because of time constraint, we cannot look into each and every type, right? So we have picked up one of the best model and commonly and widely used, that is the ARIMA model. So model uses the dependency relationship, nothing but the correlation between an observation and some number of lagged observations. So this is what I'm talking about, autocorrelation. We find out the relationship between the observation and the lagged observations, right? So what is the relationship? How the relationship means? Take a simple example, friends. Like in the schooling, we might have discussed about speed equals to distance by time. Now, there is some relationship between speed and distance. So, let's say if time is constant and if a distance is increasing, speed will also increase. They are directly proportional. So, if speed is increasing, distance is increasing. And so, they do have some strong positive relation, right? One is increasing, other is also increasing. So, this relation, we call it as correlation. Similarly, here we also understand the relationship between various variables, right? And yeah, but because it is a time series data, we cannot directly find out the relationship between our data, but rather we use something called as autocorrelation, where the lagged observations are considered. So the current observation and the lagged observations, nothing but our past observations are considered, and the autocorrelation between them is found out, which will help us to analyze about the data. So, and also ARIMA model is integrated, and it also uses differencing to make time series stationary. So yeah, it is already present within the method. And finally, it also uses dependency between the observation and the residual error from the moving average model applied to the lagged observation. So when I say residual error, so you might have studied about residuals in your regression concept. So when we are trying to predict something using a regression technique, nothing but equation of straight line, and if we are not able to predict properly, which means we have some error, right? That error, we call it as a residual. So we can easily identify the dependency between our output as well as the error in the ARIMA itself, right? So let's say you have, let me simply draw this. Let's say you are able to forecast it, you are able to build a model like using this additive model. And this is the plot we got, the simple plot I have taken for easy understanding. And let's say here I have a predicted data, right? Let's say for month of June, my predicted data is maybe my predicted sales is maybe 20 sales, but my actual data is 40 sales, right? So 40 and 20 means it is not matching, they are not same, there is some difference between them, right? My prediction is incorrect. So this difference between these two is called as a residual, right? So we can easily identify the dependency or the relationship between the residual as well as the output, the observation within the ARIMA itself, right? And this is one advantage why we use ARIMA. And next we have something called as hyperparameters. So hyperparameters are something which are experimental. So we usually change something in our model to get the better results, to improve our accuracy. Just now I said my model predicted the drug sales will be 20 per day. When I'm doing a daily sales forecasting, let's say for a cetirizine, it is said that my model said that, so per day, you will be selling 20 samples, right? But my actual data was 40. My output is 20, means my model is not performing correctly, right? It is incorrect prediction. So in case of incorrect prediction, we have to change our model. So I have put so much of effort and I've built from scratch, collected the data, did feature engineering. Now I am building the model and now my model is not performing well. So, now you no need to again do from scratch, right? No need to do all that process from scratch. But rather, we do something called as hyperparameter tuning, which means certain variables we change within the model. So inside the model, we'll change some sample things. And when I say all this equation of straight lines, hyperparameters, all these are mathematical things. I understand that you might think why we have to learn all mathematical things. It's not necessary to learn everything, friends. Everything is built in inside your Python. You just need to import them, throw some data, dump some data into that function. It will give you the results. In case we are getting some error, higher error, some small minor changes you have to do. Nothing but these are called hyperparameters. So in a function in your Python, you need to change some values. So yeah, definitely we'll look into the code maybe tomorrow. So I'll show you then how can we change them. So let's for now let's understand what are these parameters are. Like if you change these parameters are called hyperparameters. If you change certain values, automatically your model will learn more patterns and it will predict you better output, right? And these are called hyperparameters and the process is called as hyperparameter tuning. And there are namely three parameters. They are P, D, Q. So of course the naming is given as P and D and Q. Like as you can see here, P, D and Q. So this what does P do is, P is nothing but a lag order, right? The number of observations in prior time steps included in the model. So how many time steps we are lagging? So typically it is equals to the lag at which we have the ACF cutoff. So basically in simpler words, how much of lag we are taking. So when you are comparing the data, am I taking lag 1? So when lag 1 means I'm considering, let's say if it is a daily data, today is Monday, I'm considering previous day, let's say Sundays. So I'm considering Sunday's data. If it is lag 2, I'm considering 2 days before Monday, right? Saturday. So like that, this p-value indicates how much lag you're considering, right? And then we have D. D means differencing degree, right? D means differencing degree. So number of times that the raw observations are differenced. So if the data series is stationary, so D equals to 0, and if it is not, D is greater than 1. Right? How many times we are differencing the observations. So this we call it as a D, right? It is represented using a variable D. And then we have Q. So Q is called as moving average order. So the size of moving average window. So average means you all know mean. The basic mean, sum of all observations by number of observation. So how many observations you are considering? So are you considering first 5, next 5, or first a few days, first 5 days, first 10 days, first 6 days? So how much of, what is the size of your window? It tells about the Q, right? So these are the parameters that we have in ARIMA. So these three are called as the hyperparameters, and we tune the hyperparameters to improve our accuracy, to predict the better results and the accurate results, right? And so if we move into the next slide, we have some certain common rules that we have to follow while implementing the ARIMA. So we have here rule 1. So if the series has positive autocorrelation, So we saw what is autocorrelation. Autocorrelation means the relationship between the current variables as well as the lagged variables. Lagged means we have taken the previous day or previous months or previous year's data, right? Based on whatever data we consider. Let's say if I considered the daily data, then my lagged, when I say lagged, I'm considering 1 day before, 2 days before, 3 days before the data, that is lagged. So in the rule 1, it says that if the series has a positive autocorrelation out to a higher number of lags, then it probably needs a higher order of differencing. So your D value should be greater. So when we have higher number of lags, I was saying 1, 2. So if it is 10, if it is 12, if the lag is 12, if the lag is 10, and if it is higher, then the differencing, the order of differencing also should be high. Your D value should also be high. If P value is high, your D value also should be high. And if the lag 1 autocorrelation is 0 or negative, and the autocorrelations are all small and random, then the series does not need any higher order of difference or differencing. So if the autocorrelation is negative, then we don't need higher order of differencing. So D value should be as low as possible, right? So if it is lag 1, autocorrelation is minus 0.5 or more negative. So the series may be over differenced, right? According to the statistical forecasting. So these are the some common rules that we use when we are taking up the P value and the Q value, right? So this is about the ARIMA, friends, and of course a few more points we have to discuss, and we'll also see how can we implement and what is seasonal ARIMA, and also we'll also look into some part of code tomorrow. And I think we are almost up with the time. Let me do one thing. I would like to take your questions. If you have any questions, we can discuss and we can wind up for the day. So we'll meet again tomorrow and we'll take it forward. So thank you, everyone. I'll be waiting for your questions. And meanwhile, I'll be sharing you a quiz question in the LinkedIn. I would request all of you to please answer the quiz question and try to recap what all we discussed today. And if you have any questions, you can please post them in the chat in the YouTube comments. So I can quickly view them and I can reply to that. So I have shared the link in the quiz link in the YouTube comments. Please try to open that link and try to answer the quiz question, friends. So I hope everyone had a great session. So if you have any questions, any queries, please let me know.